Okay, so welcome everyone to this second session of Cormas e-training, which focuses on the pub setter, so the new features to display agents on the space interface. That will be the first focus of this e-training, and the second one will be on the new features of Cormas 2014 for displaying probes, so graphs on to follow the course of the simulation. So the session will be based on the ESSEC models. I'm opening the class for each of the entity in order to see what are the entities of this ESSEC model. So I have a plant, which is a spatial entity, and then a forager, which is an abstract class, which means an abstract class. It means that you cannot create instances of that class, but it is to define a model of agent. So within under this forager class, there are two concrete classes: restrained forager and unrestrained forager. And those classes, as they are concrete, you can create instances of them. So we have this abstract class to define a superclass that is the model of all type of foragers. So just to remind you, so visualization, when you open the space interface, so when you open it, it is blank, and then finally the simulation module here. So when you open it, so you have this red button to initialize. So we will go for the homogeneous environment initialization, and I will select probes here. So for those who are not familiar with how to select in Cormas interface, if you want to select several of them, then you have to hold shift. So you just click this one, and then I hold shift on my keyboard, and then I go to the last one, and all of them are selected. Then I go for apply. The simulation is ready, and if you go forward, then the simulation is run. So what we will look at now is how you can define or redefine how the agents are displayed. First thing you have to remember is that in Cormas, everything is the display is defined through point of views. So if you go to programming the observer, and then space and entities, you have this POV setter, so point of view setter. So this is, if you compare to Cormas 2012, this is a bit different. So you have this notebook format. So here is the definition of the point of views for the plant. So the plant is the cells here, for the restrained forager, for the unrestrained forager, and for the superclass, so the forager. So there are two things to define a point of view. Is the method which is called to display the agent. So for example, POV food or POV veg class, and here the symbols that are associated to these two different colors. So I will explain a bit more. These are methods. So actually the class plant defines those methods. So if I double click on this POV food, what does this POV food do? It says, okay, it sends back, it returns the value of this method, which is a method that sends a color according to an attribute, which is energy, and it says, okay, from min to max, a min-max value of this energy attribute, then give a gradient of color in a green color. So this is one way to define a point of view. Another way is this one. If you go for POV class here, you can also say directly send the color for a certain condition. So here, if the energy is below 1, then you send white or dark green. So I'll close this. I'm not sure what it is. Okay, so that is
what is the meaning of class?
Here it is the modeler who decided to call this method class. He meant type, I guess, or ranges, perhaps POV classes or ranges or types. It's him who decided to, but it has no meaning, specific meaning within Cormas.
Okay.
Here in that case. Okay, so that is one thing. And now if we go to agents, so here you see that for an agent, for this agent, you have three type of point of view. So here, if I go to POV forager, I can display it with POV energy, which is the one which is chosen by default, or the default POV. Okay, so I've clicked it and it shows the agent in a different way, or POV ID. Okay, POV ID. So how does this work? If you go to default POV, what does it say? It returns class name. So the class of this agent is either restrained forager or unrestrained forager. The fact that we as its name, it returns the symbol of that name. So it returns a symbol of unrestrained or restrained forager. And here, if you look at how within the, if you go to the folder for restrained forager, you see that here the symbols, this symbol corresponds. So if I get default POV here, so when the symbol restrained forager is called to be displayed, then it shows this figure here. This so if I change it here, okay, if I change it, it will up. Check how to change it. Okay, I'll make it a fat tone. Okay, you're about to change the image. Okay, yes, and then I go for apply. It changes here.
Okay.
So this is what you have to remember, is that these methods here, they send either a color or a symbol. And if it is a symbol, then it would look at what is the color and what is the shape of that symbol. So this is how it works. Yep.
And this is the same for the plant? It's a symbol or a color?
Yes, it is the same for the plants. So here you could have eventually create new symbols here, and you will say, I don't know, poor. No, perhaps I will choose poor vegetation. Okay, and then within, so poor vegetation, I will define it as being yellow.
Okay, so you have to draw something?
No, and then within POV class, for example, I will take POV class. Okay, in case it is lower than 1, then I would say, okay, return the symbol which is poor veg.
Okay.
Sorry, symbol, this character.
Sharp.
This, yeah.
Okay.
So then I accept. Now, if I choose to display the vegetation, the plants, using the PovVesh class point of view, then all of them which are white.
Okay. Great.
I can eventually do something more tricky, which is here. I say if it is below 1, then you send this specific color, and if not, then you use the previous method, the one that gives a gradient of green. So then this method is PovFood. We saw it before, and I need to put a little hat here so that it returns its value. Okay, so now I'm done. I have to refresh in that case, and then
okay.
So that is the basic principle of POV methods that either send back a color or a symbol. And if it is a
or
symbol,
a draw.
Or sorry?
Or something to draw.
Yeah, something to draw. Well, if it is a symbol, then this symbol has to be defined here, and it is the symbols defined here that says if it is that gives a specification of the shape and of the color. In case of a spatial entity, it has only the color, and in case of agents, as the color plus.
Okay. Okay, there is no shape for plants, for example.
No, they have no.
Okay.
The plants, they are squares. In case the environment has been defined using a cellular automata with squared elements.
Okay. And if you want to use as a symbol a number or letter that is typical from each instance.
Yes.
Is it possible to use ID number?
No, for the first character cannot be a number. So if I try to do, I don't know, 111. Okay, so just to say that I was wrong, it works. So as far as I remember, I was always cautious with that, and I was not using a number as a first character, but it seems it works.
Instead of the code, the drawing or symbol, can you identify the agent with only the idea? Let's say agent 1, 2, 3, 4, 5, and it appear on the spatial grid.
You can display the ID with another stuff, which is an addition to the point of view, which is display info. Okay, so display info here. If you go here and then go for forager info ID. How this works, this info, okay? So you have them for plant. Here I am on plant. So here I have those stuff, info energy, info class name, info ID. Restrain, I have only these two, and forager I have 3 of them, etc. I will come back to plant. Just to tell you that actually here in this case there are 3 info which are defined. The one which are below this line are the one that has been defined by Cormas by default automatically when you create a class standards. And this one, it is the modeler of the ESSEC model who defined it. So for any agent or spatial entity, there is always the info ID that you can find here. Display info. So even for the plant, you have the info ID. Up. So it makes a lot of ID. So I will remove it for a moment. So I'm not sure what happens. So there is nothing to do with these two. They are just there, and that's it. So you can also display the name. Okay, the name of the class. So for example, the agent, where are they? Display info.
Okay, normally they have all the same name.
Okay, so here you see this one is a restrained forager and this one is an unrestrained forager. Okay, and the modeler, he created this one. So I will show you how it is made, and then we will create another one. So I double clicked. When I double clicked, I entered the method which is behind this info energy. And what does it say? It has to return a string. I remind you that a string is a way to display a collection of characters in Smalltalk. And I'm surprised because I thought that here we would have found self energy rounded. So rounded is to make it rounded on a number. I thought we would have found print string, because print string is the instruction for to convert a value into a string. I thought we would have found that. Perhaps Cormas is smart enough to convert by himself a number into a string.
Yeah.
Perhaps that's why. But remember that it has you have to return a string. Okay, so info energy is print string, so it gets the energy and converts it. So if we go for forager POV energy, we're on the plant POV energy. We are on the plant, or where are we?
Yeah, plant.
Info plant. Okay, so that's it.
Okay.
You cannot, unfortunately, you cannot choose the color of the string, so it has to be black. Neither the size of the string. It is fixed for the moment. There is no. For the moment, it's like this. But sure, what I can do is that. Okay. But so here, if you decide to change that and to, I don't know, to
42 reply.
Yeah, if you decide to say hi, okay. So
it should work, yeah.
Okay, this comma, it is to define a string in Smalltalk. Yeah? So now I redisplay that info plant. I just click where I was. So all of them say hi, but you can be smarter. Okay, you can say, like, I don't know, self energy below 1 if true. Okay, I don't know, problem. Okay, you have a problem. If false, nothing. So nothing, what will you return? Sorry. You will return just a blank string. So here I'm putting 2 comma, one after the other. Okay, and I forgot a little hack for that, because you have to return something.
Yeah.
Okay, and then so all of them have problems. Here, there are some of them we cannot see very well because there is still the name of the foragers that are displayed. So I will remove them. Info forager. So you see, it's this class name. I will put on nil. Okay, so
okay.
So you can do things like that, like this. If you want, here we have changed we have changed one info method, but you can also, of course, right click here and add. Actually, it would have been better. I should have done that at first. Info problem. Okay, so that is our info problem, and that would have been even better. So I will take this one. Just up. So this is the info problem, and this is the info energy, which I shouldn't have changed, but I will not rewrite it. But anyway, that was for the. So info plants up here, you see, Cormas did not recognize that there was a new info. Okay, so it does not appear. So what you can do is reopen. You go for environment here and then reopen. And then, okay, you have to close the previous one. So sometimes sorry?
So how do you know that an info method is an info method, in fact? Just because of the name?
Because of the name, and even more precisely, because it is stored in a protocol called info. Actually, what Cormas does is that to know which stuff he has to display here, he looks at all the methods which are in the protocol info of that class, of the plant. Okay, so within the other class of the for the other entities, you will also find an info protocol here. So if you want to be another way to define a new info, you just eventually you don't need to go like through this interface. You just go to your class. So I will do it all from the beginning. I am here, I go for plant, I open, I go to info energy. Here I can define another one, and I can define, even I can choose not to call it info. Okay, I can call try to call it afficher problème. Okay, afficher problème, which means display problem, problem in French, and then I just accepted the method. So now I have 3 of them, and here it doesn't appear yet because I have to reopen for the interface. Okay, tools, display.
Yeah, it's
and then
so it's a bug that it doesn't appear immediately, or
it's a bug. It's that I think we were lazy to implement the method for the menu to be refreshed. That's why. So and here, so you have it afficher problème. Okay, so you can call it the name you want.
I have a question, Nico.
Yes.
When I use this info to display a specific attribute of an aggregate,
yes,
that changes over time,
yes,
it doesn't refresh automatically. I need to refresh it manually.
Okay, so that may happen. That happens. One way to do? Okay, for example, so you have this POV energy of the foragers. Why it does not display? Tac. Oh, no, sorry, I'm on the POV. So sorry, info forager, info energy. Okay, and then I go 40, 39. So I'm testing for them at the moment, and it works. Huh? Why does it work actually? It works because something changed to that entity. If nothing changes to that entity, then Cormas will not ask for the display to be refreshed. Okay. What for to specify that the space interface has to refresh at a certain moment, you can use you have to set the change of an attribute as notifying to the space interface that it has changed. I will try to be more precise, more clear. If you go to the attributes here, okay, if you go to the attributes, for example, forager energy. Here, if you have selected forager energy, and then here you have something which is called notify observers when changed. Who are the observers? What is meant by observers? This term observers are the space interface, so the one or several space interfaces, or eventually other observers such as the charts or things like this. Here you have if you click on this, then it says, do you want to remove the update of the space window and the other observers when the value of this attribute is changed? So it means that for the moment there is a notification when it is changed. So I want to keep it eventually, so I will say no, so I will not change. I will not change. So here there's already a notification. So what you can do for Anne is check on your aggregate, check that the attribute of this aggregate has the notification of the observers activated, enabled. So you go for for one observer. Sorry, attribute here. Here plant, notify observers. Do you want to remove? I will remove, okay? And now if I keep going, you see that nothing changed.
Okay.
But the value changed, okay? Here it's 0.11. Sorry. Okay, 0.11. It changed, but no, the color doesn't change. Okay. So I'm not sure about the issue you are facing, Anne, but it might be resolved by doing that. Is that you go for the attribute that is changed, and you say notify observer when changed. Do you want to update? Yes.
Okay, cool.
You should try that. And then now, yeah, it was really poor, because the yellow is defined as poor energy. For food, okay. Okay, so that might help. And to answer your question, to answer your question again, Anne, the values, the info, are as well refreshed when the agent receives a notification. So when we say when we specify notify the observers or the space interface when changed, it will update the color, but also the info. Okay, so if the info has changed, eventually the color doesn't change, but the info should change. Then because you have notified the observers, it will do it. Why it is not done by default? It is because it takes some resources, and in some cases a lot of resources. So the philosophy of Cormas is that by default we don't notify the observers because it takes a lot of resource, and then it is to the modeler to specify, okay, notify the observer for this or this. So be cautious about specifying a notification on the right attributes. Okay, some attributes they change, but you don't need to notify the observers when they are changed. Here I click POV energy. This is the basic symbol. Okay, so the basic symbol is this hexagon. So I can change again. You've seen that. So I will do it again. Sorry. When I click on this icon, then I can change the shape. So here are the basic shapes, and then if you click on it, then you have two types of dots. Here it is to create a new one, the gray one. You see, here I click, and then it creates a new dot, a new black dot. Okay, so now it is a little cats. Okay. Seems it didn't work, or why? Little cats. And the black one, it is to move a dot. Okay, so here it is a little rabbit now. Okay, so I have to ask for it to refresh.
Okay.
Here it is a libraries of shapes. Okay, so I can choose to be like this now. So once again, the apply does not apply, so I have to do it again. Apply. And actually you have two ways. Either you display an agent using vectorial. So if it is vectorial, then it means that you can always come back to the dots and then change the dots, okay? Or through a bitmap. So a bitmap, here it is a design, and then you can have colors or several colors. But in that case, okay, I will do it on unrestrained. I will do it here, okay, on this one. In that case, you cannot have a gradient of color because a bitmap is fixed, and you cannot change programmatically its color. So I have to do it on a symbol that is not used for a gradient of color, such as the POV energy. POV energy is used as a gradient for a gradient of color. So here, how it works? So you can just you select the color and then you draw like this. Okay, it is very basic. There is not a lot of shapes or stuff, so it is dot by dot, or you can draw areas. Okay, so here, and it draws black, but actually it is a bug, or it is a bug. A bug. It is a bug. So actually the black lines that I'm drawing now, it is not for real. So then I click on the left button, and then I hold the click, and then I draw a blue stuff, and here I go for violet or purple, and then so don't look at this black stuff. So I go like this, and then it goes for violet. Okay, and then when you finish, you can go for install. You're about to change the image. Okay, so now my unrestrained forager is displayed like this. So this symbol is used when I use to display the forager by its default POV, and of course, just to make me voilà, apply. Forgot to click on apply. So now all the unrestrained forager are displayed like this, which has not much meaning, but just for the example. And what you can do also is capture, and then I can capture, I don't know, I will go for, I don't have, you can open an internet, you can browse the internet and look for an image, and then when you are on your screen, then once again I click, hold, then I draw a little area, and then I release the button, and then I capture that, which is okay. I will do it again. The image has been altered, but do you wish to discard? Yes, that's a bigger one. Check. Install. Yes. Apply. Okay. And that's it. So you can eventually do that. The last thing you can perhaps to be said, it is when I captured, there is this this green and this green, and then I install. Okay, say yes, and you see that this dark green area has disappeared. What does Cormas do? In order to avoid when you capture, and if you have a lot of blank area around the shape, okay, if your shape is not a square, and the bitmap you want to display is not a square, but it's something with a specific shape, then actually Cormas looks at the color of the most top left pixel and says that this color will be the transparent color. So you see this color here he says he sees it as from the top left as the transparent color. You have a library also of figures, so okay, you can say it will be displayed like this. Very funky. So POV energy, position on the cell. Okay. So here I have defined it very small, and then so here if it is here, it is at the middle, and then up on the top I have to ask for it to. Okay, so top left, so it will always display on the top left sorry, on the
Okay.
top of the cell. And here, if you go, so I don't know, here it will appear about here.
The idea is to be able to display multiple agents on the same cell?
Yes, yes, yes. In this model,
Yeah? Okay.
in this model, they are not allowed to be several on a cell because of this is the specification for the model used for this model. But you can change this, and in that case, okay, it is interesting what you ask. So I will change it. Okay, so I'm opening the forager class. I go to biology, move, because I know that it is here. And you see here, the random walk is constrained by the fact that there shouldn't be any occupant. Okay.
Yeah.
So I will just change that. Huh? Okay. I will do a normal random walk.
Okay.
I think the method should be this one. Okay. Okay, so let's do it. So I might have several on the same one. Perhaps we will see from the ID. There are two ID displayed. I'll just create one. Stop. And restrain 15. No, I didn't manage to create a new one here. No, we'll put another one. Create. Ah, there. Because I was clicking on the, I think on the text. So stop. Stop. I close. How many agents do I have here? Plan 2. Ah, I should be here. Okay, I should click here. That's it. Unrestrained 50, 71. So what I can do here to finish the example, I can say, okay, randomly, and then it will be anywhere randomly displayed. So if I go refresh, POV, energy, so I can see that there are a lot of them here. Okay, so that is useful when indeed when you have in a model when you have the possibility to have several agents at the same place, and then it is much more convenient to define the position as being random. So to open a chart interface, so you go for visualization and then prop, so you can have two of them, as many of them you can have, and then you go for select, and then you choose so first thing is that as usual you can choose to display several props at the same time. So if I hold my shift and then click all of them, then so there is one thing you can do. Okay, you can zoom to a specific area, so you have to do it eventually like this. So I say, okay, I go from 30 here. You see when I move this cursor, this slider, then it is the minimum range that changes. It still not applies because I have to click on zoom. So I want to move zoom from step 35 to step 51, and I go for zoom, and then or then default, and you come back. Another thing you can do is that you can change the color of the charts and have these colors defined as default for any other simulation or any other simulation that you will do with this model. So that was something that was asked by Cormas users. So you can go for options and change line color. So here, what I'm doing is that I will say, okay, so restraint size, I will display it with red. restrained energy with pink, unrestrained energy with navy blue, and unrestrained size with light blue, and then plant energy with green. I go for apply, close. As usual, you need to refresh. Okay, and now so it displays with the color I have said. But even more interesting is that if I close the ESSEC model and reopen it, it has these settings are registered, which was not the case before. So I will close this window. So if you save the model, okay, and I say Session2, then these settings are registered and remembered by the Cormas. Where you might ask yourself where it is stored, or it might be useful for you to know how it is stored eventually. It is stored within the class of the model. So here, if you go, if you inspect, if you browse the class of the ESSEC class, so it is the same class that it is used for initialization or scheduling of the simulation. Here I am on the ESSEC class. Okay, if you look at the, so here it is my initialization methods as usual. Here are my control method as usual. And if you go for class here, you see that here there is props. When I've defined the color previously, it has created those methods. So the color for plant, the color for plant energy will be always color value green. The color for restraint energy is it will be like this. So this is how it works. If you have local probes, so probes which are specific for one entity, it will be the method will be saved in the class of that entity. So here I have local probes, local for restraint, okay, energy, and if you define the color for this energy probe, okay, this energy probe of the class restraint forager, then it will be saved here in the class methods of the restraint forager class. I come back to global. For those who are not familiar, in Cormas there are two types of probes. The global, which are used usually to show a probe on a population, and local, which is to show a probe on one specific instance, one specific entity. So that is one thing you can do. Another thing you can do also is display the markers. Okay, so you see all the dots. You display.
Nicolas, so can you just look at where you find the probe in the class?
Yes.
For your global
Sure.
Global probe.
Yes.
You visualize it, and I can't really.
Sure. When you are, so yes, I was a bit quick on that. When you have displayed your probes interface, so here or this one or the other, here you have the level. That's it. Yeah, that's okay. The one. Global, so that is the global probes, and local, and then each of the class appears. So one thing which might be useful as well, it is this duplicate window. So here, let me do it a bit smartly. Here I have plant energy. Okay, so I will display, if I display the values, not so well. Anyway, okay, okay. You can also ask not to show the step 0. For some, usually when we do role-playing games, we go for only a few steps, okay, for 5 or 6 steps, and then the step 0 might be unrelevant, so then it doesn't display the step 0, okay. So what I wanted to show you is duplicate. Duplicate will allow you to compare two simulations, okay. I click on duplicate. Here, this is my simulation number 1. he proposed me a name, okay, sim1. Why he proposed me, suggest me sim1? Because actually, if you look at here, sorry, I will cancel just to show you. Here, this interface. Oh, what did I do? Windows. Thank you, Windows. Okay. You see that here there is a new stuff which is which defines which simulation it is, because since I have opened ESSEC, it is the first time I've clicked on I've initialized. If I click on initialize a second time, then I will be on sim2. So this duplicate, it is to compare two simulations. So this one I will store it as being simulation 1. So I have a new interface, and then I initialize again, up.
Okay.
I can eventually close this. I don't need it for the moment. Okay. This, I think it was before. So this one will not change. And I went to until 94. So I go for 94. So this is sim2.
Yeah, there's nothing written on the top.
Yes, indeed, yes. Well, it is the one that I've just done, so I know it is sim2. Yeah, yeah. It's indeed, it's not written sim2. Yeah. Well, this one it is written sim1. And then you can compare like this. Usually, what we did, the other way to do is, of course, to save, to export the data. Either through ASCII file or Excel. So what else can you do with this interface? Okay, you can change where you want to display the legend. So this is the legend here, plant energy. So I can put it on top left. This is just, you can hide it. And scale to min max, that it is the same to, no, it's not exactly the same, sorry. This is to scale on the Y axis. Okay, and display sim information. Okay, sim1. That is what you were asking for, display sim. Okay. So this is the information of that sim2. Simulation. You see that the random seed is different from one to another.
Yeah, I have a question.
Yes.
Is it possible to put on the same windows the two probes to compare with another simulation?
No, it's not possible. It's not possible. There's no way for the moment to do that. So you have to, yeah, you just have to be. I'd like to compare like this.
Okay.
Yeah. What I personally usually do when you can export to Excel, when it doesn't work, I just export to
you
Excel.
Merge,
yeah.
Okay, so you merge with the Excel.
Yeah, yeah, absolutely. That's what.
Nicola, just one simple question.
Yep.
Could I?
Hi.
just a little simple on the observer.
Yes.
Because I observe from your screen, I can see the scale of adjusting the color.
Yes.
It's different from mine. But in fact, I'm using Windows 8.1.
Okay.
It runs fine. I can export the probe data to Excel without bug.
Okay, cool.
Probably it's quite new. it's very interesting to see lots of new features of Cormas since the last hands-on on the Cormas 2 or 3 years ago.
Yeah.
Anyway, thanks so much.
You're welcome. It's for the community that we try to to have these features. But indeed, what you were suggesting, Julie, would be very useful to the fact to be able to display the two figures on the same.
Yeah, but it's possible to make it in Excel, so
yes, of course,
it takes more time, but
yeah.
We should put this issue on the issue tracker.
Yes, that's right.
Yeah,
that's right.
Yeah.
Afterwards, if the idea is to go for a more deep analysis in terms of differences between simulation, actually, this is not the way to do it. I explain myself. Usually, we use these charts and this feature to duplicate, to have a simple comparison between two cases. For example, between two cases. Okay. If you want to go for further comparison, more into more deeply, and that will be perhaps the topic of the next e-training session. You have to go for analysis here, simulation analysis, and here you have much more stuffs. So you have three types of analysis. Either a stochastic analysis, that is to repeat, for example, 100 times a simulation, one at a time. OAT, it is one at a time sensitivity analysis. Or the last one, it is cross sensitivity analysis.